Hello, my dear young and energetic Physiodon Army. A very warm welcome to Diksha Vedantu YouTube channel. I am your master teacher Neha ma'am. Today we are going to discuss one of the important chapter and most demanded chapter. Okay, just give me a second. Let me check out. Is the live proper? Can you hear my voice? And is the screen visible clearly? Let me know it in the chat. Quickly. Yes. Okay. So am I audible properly? Yeah. Okay, so I hope audio and video is clear. So we are good to go. We can start today's session. Okay, let's start today's session of electricity. Right? Okay. Yeah. Yes, we are starting with the chapter electricity. I hope you all are doing well. You're studying well. Yeah. Yes, Vemo. Hi. Hello everyone. Okay, shall we start? Okay, let's start with our today's session, right? So you can see some of the gadgets behind me, right? In this presentation, you can see the refrigerator, washing machine, juicer, many objects, right? What is necessary for all this to run? Tell me in the chat, what is required to run a fan, run a AC, bulb, tube lights, etc. What do we need? Yes, any answers? What do we need to run these gadgets? To run your mobile phone, your desktop, computer, laptop, etc. What is required? Yes, can I know the answer from you? Yes, students, please in the chat. Electricity. Yes, absolutely right. We need electricity to run these gadgets, right? Without electricity, we cannot imagine a life. How it will be, we cannot imagine that also. It will be so disturbed, right? So to run this all the objects, we want electricity. And what is this electricity? How this electricity works? About everything about electricity we'll be discussing in today's session. And this is one short video. Yes, Lakshya, it's electricity. Yes, Vemu, it's electricity, right? So we are starting with this electricity, okay? So in one shot, we are going to cover your electricity chapter, right? So let's start today's session of electricity. Okay, yeah. Before moving ahead, those who haven't subscribed the channel yet, just go and subscribe the channel. Okay. If you have subscribed the channel only, then only you can write the chat and we can interact, right? So watch the video completely. If you like that, don't forget to hit the like button. And also, we have Telegram channel, which you'll get the link in the description box. Just go and join the Telegram channel. Okay. Before starting today's session, I want to just give a shout out to the students who had replied, who had commented the answer which I have given in the light chapter, okay? When I explained about refraction, I had given you guys a question, and yes, Pro Learner and Sarvesh, so they have given the answer. There was some errors, students, so I said you write down the answer in the comment section. I'll be displaying your names on the screen, right? So I have kept my promise. I have displayed your names. Congratulations, you have tried well, okay? No matter if there is mistake, I'll be explaining that problem too, okay? You'll get the answer in a short video. Not in this video, we're going to discuss that questions too, okay? I'm not going to leave any of the question untouched, right? I'll be explaining that. So congratulations guys. So we'll be having questions, and if you answer, you'll get your name on the screen. So yeah, let's enter today's session, okay? Yeah. So yeah, as I said about the Telegram channel, you'll get the link in the description box where you'll get daily practice question, PDFs of the session, etc. So just go and join the Telegram channel. Yeah, let's enter to today's session. Yes, Pushpa. Yeah, I'm going to cover the whole chapter. You are going to cover whole chapter. Yes, Pushpa, I'm going to cover whole chapter in today's session, okay? No worries about that. I hope you can see the screen properly, okay? There is little color variant here. It's light and dark. I hope you can see this, okay? First, we'll be starting with electric current. What is electric current? Why that? We'll start. And we'll know how the electrons flow in the conductor. Why do they flow? And what are the things around that? We'll be discussing about electric potential difference, electric circuit, right? And also how to draw the circuit diagrams, Ohm's law, right? Yeah. To all of you, yes. Right? So yeah, let me tell you, Ohm's law, Joule's law, resistance in parallel and series combination, everything will be discussed in today's session. Yeah, happy Rose Day to all, right? Yeah. So let's start with the current. Yeah. The questions will be there, and yeah, let's see how the session goes. So let me start with a very basic thing. What is electric current? So I hope you guys know this, right? So tell me in the chat what is electric current, and also you can see on the screen, right? So it's not a question, we have the answer here only, right? So not only this definition, we have alternative two definitions also for the electric current, right? So see, okay, let me explain you electric current with very basic concept, okay? We know about water current. Do you guys know about water current? What is water current? Yeah, what is water current? It will be flowing from a higher region. You have seen the joke falls, waterfalls and all, right? So what will be happening? The water will be flowing from the upper region to the lower region. Yeah. Why? Because we call this region to be high potential or high pressure region. Yes, and this region is low potential or low pressure region. So water will flow. Magnetic effects and electric current, yeah, it will be done tomorrow, right? Today we will be covering about your electricity chapter. Yes, Shreya, magnetic effects will be done in tomorrow's session, okay? Today we'll cover electricity and your entire physics will be done by tomorrow. No worries about that. Yes, magnetic effects and electric current. What are you asking about the magnetism chapter? Magnetic effects of electric current, that will be done tomorrow. Right? I hope you got the answer. So similarly, when how water falls from higher region to lower region, yeah, important bhi bataungi, okay? Okay, there is no jaldi, we have to learn everything, okay? Important. If you want to know what are the important concepts in every chapter, I'll be bringing separate video for that, okay? Okay, so yeah Bittu, it will be in separate video. उसके लिए दूसरा वीडियो आएगा, okay? Wait करो. तो आज हम electricity पढ़ने वाले हैं, right? In that video, I'll be discussing from light chapter, from electricity, everything. Thank you. Okay, so how the water flows from a higher potential region to lower potential region, okay? Similarly, electricity will be also flowing from higher potential to lower potential region. Let's be simple and answer this. Okay, the ID is like that, right? The ID, I have just read it. Okay. So listen, what is electric current? The rate of flow of electric charges is called as electric current. Now how to remember this? The rate of flow of electric charges. If water flows from one region to another region, we call it water current. If air passes from one region to another region, we call it air current. If electric charges pass from one region to another region, we call it as electric current. Is that clear? Is that clear? Okay. Coming to the formula. Simple. So tell me, students. So tell me, do you know the formula to calculate charge? Tell me, write the answer in the chat. I want to see. What's the formula to calculate charge? Q is equals to dash. Tell me that quickly. Yes, students? Yes, what is the formula? Q is equal to? Can I know quickly? Yes, Shreya, Sanjana. Yes, absolutely. I is equals to Q by T. Shreya, yeah, Sanjana, she had written that. It is absolutely right. Q is equals to N into E. Yeah. Okay, done students. Q is equals to N into E. What is N? N is number of charges. This is number. Number of electrons also you can say, number of electrons. And also you have another sign. 1.6 into 10 power minus 19. Value of E, right? It's the charge on one electron. Yes, Rashmi, I is equals to Q by T. Yes, it's the formula to calculate electric current, absolutely, okay. So, as the definition, see, I will be always telling to my students that whenever you see this word rate, okay, this rate is nothing but a quantity is changing with time, okay. In the definition, if you see it as rate, what it means, this quantity, okay, the quantity is changing with respect to time, okay. By the definition only, you can derive this formula. Done? Yes. Yes, it's number of electrons. Yeah, I got it. Yeah? Okay. So, and what is the SI unit of electric current? I hope you guys are getting here and no need of more explanation, right? This is very basic thing. I don't think here we have to take more information, right? Just simple. What is the electric current? Rate of flow of electric charges. Formula and what is the SI unit. SI unit is here given as ampere. Can you give another SI unit? Yes, Vemu, ampere. Coulomb for what? Yes, Sanjana, coulomb for the charge. Right. Now tell me another SI unit for current. For current. What is the SI unit for current? What is the SI unit for current? One is ampere. Another one. Do you guys know that? Yes, quickly. Do you guys know what is another SI unit of current? SI unit of voltage is volt. SI unit of volt is not voltage. No, it's simple. See here, in the formula only you can tell the answer. Okay, see here. What we have electric current? Yes, Rashmi, it's coulomb per second. Okay, see here. Electric current, the rate of flow of charges per unit time. SI unit of charge is coulomb and SI unit of time is second. So what is the SI unit of current? Coulomb per second. Right? Got it now? So ampere is one of the SI unit and also coulomb per second. Okay? I hope now you guys have understood this, right? Yeah. Let me move forward. So, before explaining you about how actually the electrons flow in the atom or a conductor, I hope you already know about the charges, right? You know about the charges. You know about the structure of atom also. You have studied it in chemistry, right? We'll be having nucleus at the center. Right here there will be nucleus and electrons will be revolving in the outer shells, right? I hope you know this structure. Done. In this nucleus we will be having positive charges and neutrons. It will be filled with positive and neutrons. Right? Yes, you guys know that. Now, we know this point also. What is this point? Like charges repel each other and unlike charges attract each other. Yes? So, without concept, we cannot move to numericals. First, concepts has to be strong because you have to write. In the physics exam question paper, there are no only numericals. There will be both theory and numericals. Okay, this is not mathematical paper to just solve the numbers. We have to learn the concepts also. Right? Okay. So, I have explained you about the charges. Now, this if we consider this to be an atom, the outermost electron is the carrier of charge, which forms a current. Okay. So, the current is carried by which charge? Hello Raj, hello. Yes. current is carried by which charge? It's carried by, what you should say, outermost electron. Okay, outermost electrons carry the charges, they form the current. Okay, so here we have a presentation. Look at this. So what is happening here? So see now, this electron is jumping from one to other atom. You can see, right? The electron is jumping from one to other atom. So this movement, rate of change of charges, is nothing but current. What is that? The charge is moving. When the charge moves, it produces electric current. Got the point? When charges move, they form electric current. No, other electrons do not carry the charges, okay? Other electrons, because they are bound with the force of attraction with the nucleus. Okay, only outermost shell. Only electrons present in the outermost shell carry the charges, because these inner electrons will be in the force of attraction with the nucleus. I have given you this opposite charges, they attract each other, but here the force is less, so it will flow. Right? Okay. So now you guys understood how the electrons move. Okay. Before entering to the question, let me state you, okay, if we consider this to be a conductor and we are connecting a battery here, so let's consider electrons in the conductor. Okay, like charges repel each other and unlike charges attract. So this is positive terminal, this is negative terminal. Electrons are negative charge particles, so it moves in this direction towards the positive terminal. Now tell me the answer. What is the direction of current? So option 1, the direction is this, or option 2, the direction is this way. Tell me the direction of current. Yeah, what's the direction of current? 1, 2. Or else write A or B in the chat. A or B. Quickly. Hello Rajni. Option 1. Okay. Then students. Yeah. What's the direction? Rashmi 1, Vemu 1. Okay. Then any answers? A, fine. 1 or A, both fine. Okay with that. Okay. Yes, Sanjana. Yes, Raj. Yes, absolutely. You know why? Because, yes, Sanjana, Rashmi, Shreya, yes, everybody, it's the right answer. Because when they have discovered this electric current, till that time, they have not yet discovered electrons. So they thought, what is the positive charges? The direction of positive charges were considered to be the direction of current. Okay, the direction of current was considered to be the direction of positive charges. Hence, option A is the right answer. Absolutely right. So remember this, direction of current is opposite to the direction of electrons. Ankush, okay. Okay, done with that. Yes. Ankush, okay. Yeah, we shall move forward. Right? Okay. So we have a question. Now, yeah, you were asking for the question, no? So tell me the answer. Tell me the answer for this question. I'll be also solving this. Solve the question and tell the answer. Okay, if you pass 500 milliampere of current through a bulb, how many electrons, okay, will pass through in 5 minutes is the question. Thank you so much. Thank you for that, Sanjana. Ma'am, you teach very well. Thank you. Yes, solve. I'll be also solving this. Okay, they have given current. Yeah, solve by yourself. I'll be also solving here. No worries. No worries being late, so yeah, No worry. You can join. Okay, solve this question, okay, everybody. And time is given 5 minutes. Okay, so 5 minutes we have to convert into seconds. Okay, then they have asked n is equals to how much? Yeah, can I get the answer? I hope this takes little time, right? Because two formulas we have to use here. Okay, to calculate this n, first I should calculate q. Q is equal to plus or minus Ne. So let's not focus on this plus or minus. It's just to represent positive or negative charge. Yeah, what is that? 100. Yeah, what is that? Okay, let me try. N is equals to Q by E. So Q is, sorry. Okay, first I have to calculate Q, right? So see here. So I told you we have to use two formulas here. One is, yeah, I is equals to Q by T. From this formula, I will be calculating Q is equal to I into T, right? Yeah, that formula was right. Yo, let it be. Milliampere. See here, milli means 10 power minus 3. Okay. I have removed this milli and introduced 10 power minus 3. Is that clear? Right? Okay. Let me put now. The value of current is 500 into 10 power minus 3 into time is 300. So again 3 5s are 15. Right, I'm not getting the answer in the chat. Tell me what is Q. I have calculated here. I have not got the answer yet. You students will be asking for numericals. When there is numericals, you have to solve quickly and give the answer, okay? 3 5s are 15. Okay. Here 2 0 minus 3 minus 1. Okay. So yeah, it is okay into 10, right? This 2 zeros, this 1 0 cancel, and yeah, it is 150 coulomb. Yes, what's the answer? Hi. Electrons. Okay, is that number of electrons? Ankush, right? Okay. Yes, Aftab. Vemu, yeah, 500. What is 800, Aftab? Yeah, see, yeah, coulomb, right. Let's move. Let's calculate number of electrons. So it is number of electrons is equals to Q by E. Q is 150 and E is 1.6 into 10 power minus 19 coulomb. Okay. So if when we have to multiply, when we have to divide, when you are converting, when question has milli and you have to convert, you multiply it with 10 power minus 3, okay? If this has to be written in milli, I will, instead of 10 power minus 3, means 0.5 ampere, I will multiply here 10 power plus 3 to convert it into milliampere. Getting my point? So don't get confused. If you want to convert to milli, if you want to remove that milli, you will multiply with 10 power minus 3. If you want to introduce the milli in that number, you will multiply with 10 power plus 3. Which one? Conversion? Which one, Raj? Either the problem or conversion. Okay, Ankush, welcome. Raj, which you want me to repeat? Is the problem or conversion? Which one? Till here, is it clear? Till getting 50 coulomb, is that clear? Tell me. Yes. So we have to discuss more concepts today. Let's be quick. Yeah, tell me. I'll be explaining that, Raj. Which one you want me to repeat? Okay. So yeah, if I convert this, where shall I write? I'll write here. It's 150. And if I make this 16, right, into 10 power minus 20. If I take this upward, plus 20. Yes, full question. Okay, so quickly, okay, let's not waste more time in this basic things because we have to study more in this session. So let's be quickly. Okay, if we pass 500 milliampere of current, so I value is given, time is given 5 minutes, we have to convert into standard units. So it is, I have converted this 500 to ampere. I have removed that milli and I have converted to ampere, right? So from this, first what I will do, I will calculate Q. Why Q? Yes, to the power 20. Yeah, Vemo, it's 9.3. Okay. Yes. Okay, I'll be doing that. Okay, no worries. So listen to this. Okay, we have to calculate Q first. To calculate Q, I'll be using current formula. Just cross multiplication, multiply the things, you will get charge. Okay, from charge, I'm going to use this formula, charge is equal to plus or minus Q. Okay, I hope Raj understood now, right? So yeah, when we calculate this, what's the number? 150 by, okay, shall I erase this? Yeah. When we calculate this, right students, so see here you are getting the value of 9 into 10 power. Yeah, 9.3 also is not a big deal, it's right. Okay, okay. So here there is another method. Okay, let me explain that method too. What I said, I use the second formula to be N is equal to Q or Q by E. Instead of this, okay, or what you can do, listen here. Okay, welcome Raj. So instead of using this formula, you have another step, that is 1 coulomb is equals to, it's given here, see, 1 coulomb is equals to 6 into 10 power 18 electrons. Okay, so when we have calculated 150 coulomb, so 150 coulomb is equals to 150 into 6 into 10 power 18, right? So this is easier than that. Okay, if you get confused with solving the point decimal numbers, this is easy, we can just multiply this. Okay, 6 5s are, it's 30, 3 0, 6 1s are 6, 7 8 9, so 9 into 10 power 18, right? Okay, here we have 1 0, I'll just introduce that, 9 into 10 power 20, right? Yeah. So this is easier than that method. Okay, you can remember this method also. Direct formula. Is this clear? Tell me quickly in the chat. First I have given you this formula. Instead of this, you can just write 1 is equal to this much. 150 is equals to 150 into the same number. Yeah, I was also thinking the background, it's little different colors. Can't see the things. Okay, now it's difficult to change here again. Okay, but don't worry, I'll be telling everything. Okay, don't worry about that. But is this clear? Can you see these things, right? The things that are not visible, I'll be telling that. Okay, sorry for that. Okay, the color gradient is like that, it's lighter here and it's darker here. Okay, sorry for that. Shall I proceed? Tell me quickly, did you guys understood this? Tell me quickly, is this clear? Yes, okay. Yes, Aditya. Yes, Sanjana. Let's move to the electric potential concept. I have a fantastic concept here. Okay. Yes, Vijay. So I have a fantastic concept here of electric potential. Fine, fine. But yeah, next time I'll remember with the colors. Okay. So do you guys have watched that Koi Mil Gaya movie? Koi Mil Gaya, in that alien Jadoo will come, right? I have bought that Jadoo here. Okay, I have bought that Jadoo here. Okay, who is this? This is our alien Jadoo. Okay. Yeah, yes, yes, students. Okay, this is Jadoo. Okay, yeah, I'll be fixing that color. No worries. I hope today's session it will be, but next time I'll change the colors. I'll just keep it black so it will be good. Okay, this is Jadoo and this is your home. It is your home. And Jadoo wants to come to meet you guys. Yes? Okay, no worries. If you didn't see that movie also, no worries. Just remember this is the alien and his name is Jadoo. That's all. No other concept to remember there. It's an alien. And where does aliens live? Do they live nearby us or very far? Aliens are from very far region. Yeah? Now don't go to the movie, just come here. Okay? Now aliens stay very far. I'll call it as infinity. And he is coming to meet you at your home. Okay? Mars. So let's consider more far than that. Infinity. Okay? Now, he is coming to meet you at your home. Okay? To come here, he have to do some work. Simply, he cannot just vanish and appear, right? Very far. So, to come here, he has to do some work. Right? Right? Getting the point? See here. First time, he came straight away to your home. This is first condition. Second condition, when he was coming, yeah, Pluto, Mars, okay, come here. Right? Okay, yeah, but when second time he was coming, a policeman got to know that he's coming to your home. Okay, this is the second condition. A policeman got to know that he is coming and he's waiting to catch him. In the third condition, everybody, media people, press people, all got to know that and they are waiting to catch him. Right? Now tell me, which of this condition, 1, 2 and 3, which of this condition is easy for Jadoo to reach your home? Tell me that quickly. Which of the condition is easy for him? Quickly in the chat, 1, 2 or 3. Here nobody knows. First condition, he'll come, right? Okay, so tell me the answer. Don't get distracted. Just by this concept, I want to make some, one condition is easy for him. Similarly, yes, Rashmi, yes, it requires work. Yeah, that's the concept I'm explaining. Okay, let's consider this Jadoo to be unit positive charge. And your home is location, it's a point. Okay. To move unit positive charge from infinity to a point, we have to do work. Right? So, what is electric potential? What is electric potential? Work done in moving. So, to move, we have to do work. As I said, work done in moving, unit positive charge from infinity to a point is called as electric potential. Is that clear? Is that clear? Tell me. Now, why I took this policeman, media persons means when there is more potential here, okay? At your home, at the point, when there is more potential, we have to do more work. No, I'm not angry. Work done to move unit positive charge. Yes, that is nothing but electric potential. Tell me now, is the electric potential clear? What is electric potential? Remember Jadoo, it is work done to move unit positive charge from infinity to a point is called electric potential. And when there is more difficulty, when more potential is present here. Okay, if the region has high potential, then it is difficult to bring Jadoo. Low potential, Jadoo will come easily. Yes? Okay then. I hope this is clear. High potential, difficult to come. Low potential, easy to come. Clear? Clear? To a specific point is called as electric potential of that point. So remember this also of that point, that particular point we are discussing about. Right? Right? Okay. Now what is electric potential difference? What is electric potential difference? We understood what is electric potential. It's the value of this position. What I can say? I can say a quantity, okay. Here there is, okay, let me draw it. I hope, yeah. Here there is filled water and here there is empty beaker. If I connect a pipe between them, what happens? Tell me quickly. A beaker is filled, a beaker is empty. I have connected a pipe between them. What happens? Yes, what happens to the water? Tell me. Can I know? Yes? Yeah, what happens to the filled beaker? The water will flow from the filled beaker to the empty beaker. Yeah, it will go to the another beaker. So this is high pressure region. In water condition, we use the word pressure. But in electrons condition, we use the word potential. Instead of pressure, we will be using potential. Yeah, absolutely. From the filled beaker, it will be moving to empty. Yes, 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 done students. Okay. So, how the water flows from high pressure region to low pressure region, our electrons also flows from high potential to low potential. You can remember with this water example, or else you can consider this condition. Okay, that's potential difference. Okay, why it is flowing? Because of potential difference. Now, this region has some potential. What is potential? I have already explained. Here, let me consider, here there is 10 potential. Here there is 0 potential. So, every point has a potential. But due to the variation in the potential, what happens? From one to another, the electrons or the water will flow. You can consider a room filled with people, no space to sit comfortably, but in the second place, people are enjoying, they are chilling. Okay. What happens? Hi Shriyukta, hi. Okay. So what happens? People from this crowded region, they want to go and sit in the free, comfortable region. So remember, always, okay, always our electrons want to move from high potential to low potential region. The difference between 2 points, okay, so you can remember here, the work done to move a unit positive charge from a point to another point is called as potential difference. Getting my point? Tell me quickly, is potential difference clear? Yeah, tell me quickly. Is potential difference clear? Yes? Yes. See here. If I consider this is a place, this is a point, it has some potential. Another hand, it has some potential. The difference between these two hands is nothing but potential difference. Yes, ma'am. Okay, Venu. Yes, Aditya. Yes. Okay. So, we are done with what is electric current, what is potential and what is potential difference. So, remember the statement, work done to move from infinity to a point is potential, from one point to another point is potential difference. Done? So, similar what I showed with the water filled beaker and empty beaker. Here it is filled with charges, empty, here no charges. So, the charges are flowing from the position where they are filled to the empty, high potential to low potential. Simple. So, that is again the same definition from one point to another point. And what's the formula? That is important. So, the formula is work done by charge transferred is called as potential difference represented with V. Yes? So, potential difference is equal to work done by charge transferred. Done? You guys now should know this formula, okay? We'll be solving, we'll be using this formula, so keep it in the mind. inside the electric field. Okay, electric field, yes, electric field is nothing but a region. Here it will be having, yeah, this is the electric field and these are electric field lines. Yes, when there is positive and negative charges, they form a field of lines. That is, yes, V is equals to W by Q. Work done by charge. Yes, we shall move forward. Right? Shall we move forward? Okay. So moving forward, we have a question. Let's all solve the questions. Yes, Ankush. Yeah. So then let's solve this. Calculate the work done if a charge, okay, charge is given moving across 2 points having potential difference equal to 15 volt. Okay, solve this question. Solve this question. Charge is given 5 coulomb. This is easy. This is a easy peasy question. Yeah, tell me the answer. This is very basic. Yeah, what's the answer? Yes, quickly students, what's the answer? What they have asked? Calculate work done. Right, what's the answer? Work done by charge. Work done is equals to this. Yeah, 75, absolutely, it's 75. Easy, no, this one question. What is V? 15 into 5. 5 5s are 25. So, yeah, 75 joules. 75 joule. Yes, students, 75. It's not 95. Why? 5 ones are 5 plus 2, 7, 75. Okay? Right. Calculate once again. Ankush, it's not 95. Right, it's 75. Okay. If you want to check out the answer, you can look at it once. It is 75 joules. Okay, no worries. No, yes, Aditya, with the formula. Another question. This is also easy, I hope. Yeah. Tell the answer quickly. Work, okay, work done is given to be 5000 joules. These are the simple questions, okay? No, don't worry about. Yes, Rashmi, it's 75. Okay. Joule of work is done to carry how much of charge? Okay, Q is equals to how much between 2 points having, again an easy peasy question. Okay, no need to solve also. You can tell the answer. Easiest questions. Right. We have to calculate charge. Okay. Yes. Work done by charge. Work done is given. Volt is given. Volt. Yeah. Charge is equals to. Yes. Can I know the answer? In the chat. Easy. This is an easy question. No calculation. Nothing required. Yes, 50 coulomb. Right. Venu, Aditya, Ankush, everybody. Right answer. It is Q is equals to 50 coulomb. Okay, this is just simple question just to remember the formula. Okay, this is not for calculation. To use this formula, these questions are. How you can rearrange the given formula and find other things. That's all. Yes, Vemu, Rashmi. Yeah, it's 50. Okay, also write the SI units, okay? While writing the answer, is it coulomb or anything? Yes, Raghavendra Yadav, yes. Use the SI units also together so that you will remember. Yes, shall we now enter to the circuit diagrams? Tell me quickly. Okay. Yeah. Now I hope we shall enter to the circuit diagrams. So remember or tell me now, I'll give you two conditions. So here with the diagram only you can know in which of these current will flow. Okay. In which of these two current will flow. It's very easy, silly question I am asking. But we should know that. In which of these two current will flow? Tell me, 1 or 2? This is 1 and this is 2. Tell me, let me know. A, yeah, right, Vemu? 1, yeah, yes, Ankush. Yes, 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 yes. In 1, why? Tell me that also, why? Why 1? Why not 2? State the reason. Yes, Aditya, closed path. Because here the circuit is closed and here the circuit is broken. So we must remember this point. This is a easy kind of question, but you should remember that if the wire is broken, current will not flow. Yes, Rashmi, yes, everybody, it's 1. Okay, if the circuit, your wire is broken, there will be no flow of current. Yes, because it's closed, because the current is flowing. Because the current is flowing, because closed path, okay. If the path is open, current will not flow. Clear? You can remember it as current want some place, okay. It wants to travel. If it is a gap, current, these electrons, they cannot jump from this wire to this wire. They can just walk, they cannot jump. It's not like that, its current is flowing, not flowing. It's about the closed and open circuit, right? So here we have in the first condition closed path. So you can remember this like what I said, these electrons, they can just walk, they cannot jump. Remember that point. You can remember this, okay? I hope that examples will help you. Right, the tricks as current cannot, electrons cannot jump, electrons just walk. You can remember that. Coming to the electric circuit diagrams. Now tell me, do you guys know to draw the circuit diagrams or not? Tell me that quickly in the chat. Yeah? Do you guys know or not? Okay. Okay, Ankush, you got it now. Tell me, do you guys know to draw the circuit diagrams? This is from your NCERT. 100%. You know it. Yeah? So, there are certain things. Just let me quickly recall these things. I hope you guys already know this. Right? So, see here. This is the symbol of cell. A cell has, you guys know it. Right. No. Yes. Okay. You already know that. Very well. Very well. Done. Fantastic. Yes. Yes. Vemu, Aditya, Raghavendra. Yes. Okay. Rashmi, Ankush, everyone. Okay. You all know that. Done. So, let me just recall. You already know this. Just have a quick recall. It's not about that. When you like some work, you don't feel it hard, okay? When you're interested to do that, it will not be hard, okay? So, see here. What is cell? Cell has a positive terminal and a negative terminal. Nitish Dubey, right? Yeah, okay. So, cell has a positive terminal and negative terminal. Simple structure of cell. If I join multiple cell, it is battery, right? If I join a cell, it's battery. So, it's the same diagram, repeat it, it will get battery. And, yeah, open switch, close switch. Open switch is 2C, this ulta C's, and these are nothing but these, every lines, okay. These lines are nothing but, what are they? Tell me, I will not tell. What are the lines represent? Thank you so much. Yeah? Tell me, just the lines. Straight lines in every diagram, what they represent. Quickly in the chat. What does the lines in every diagram represent? Yeah, I'm waiting for the answer. Yes, can I know? The chat is not appearing. Wire, right. So, these all are wires, right. These all are nothing but wires. Why it is not erasing? Okay. So, I was about closed. Yeah, wire. Yeah, PVC. So, yeah, yesterday somebody asked me, no, that wires are covered with which one? It's with PVC. Polyvinyl chloride, right? Yeah. I have gone through that. The plastic or polymer will be used to cover this wires. PVC, polymers and plastics. Okay, so see here. So as I said, one line represent wire. If three wires are representing here, nothing but wires are joined. If you join three wires, it is wire joint. So 1, 2, 3 lines are there. Okay, here wire is crossing. Here one wire, here one wire is going upon that. Simple. Okay, you guys already know this, you told, right? So I am just recalling, I am just going through the things. I am not explaining it in very much detail. Okay, and why is the bulb diagram like this? It's because of filament. Pluto. Okay, viewers are coming from Pluto, Mars. Wow. Okay, so it's the diagram of bulb, right? So this is resistance. You know what is resistance? If you are riding somewhere on the road and you are regularly getting that humps, what happens? You'll slow down your vehicle, right? So resistance is nothing but the humps on the road. So it is like this, humps. Okay? Then variable resistance. One time the road will be bulk, one time it will be down, variable. So just an arrow like this or like this. Now tell me, why do we use, yes, in the traffic? Yeah, you can consider traffic also. But traffic sometimes at least we'll get the green light, go. But in the hump and all, you will not get. Natural property develop inside the conductor due to collision of electrons. Yes, resistance. We'll be discussing about that also. Now tell me, why do we use ammeter and why do we use voltmeter? Tell me quickly. Ammeter and voltmeter, why do we use? Yes. So I'll be saying about this. You write down the answer. Why do we use ammeter? Why do we use voltmeter? So the diagram of ammeter starts with A, circle plus minus. V, circle plus minus. That's all. The diagrams. Now tell me this. Tell me this. Why do we use ammeter? Just write A, use for dash, V dash. What's the answer? Ammeter is used to detect, question mark. Ammeter is used to test the presence of current. Yeah, it's used to determine the current. Yes, Aditya. And what voltmeter and what about others? Tell the answer in the chat. Yes. To measure the current. Yes, ammeter. Yes, Raghavendra Yadav. Yes, absolutely. Rashmi, ammeter to calculate current and voltmeter to calculate voltage. Yes, absolutely. To determine the voltage. Along with that, tell me which is connected in series and which is connected in parallel. Which is connected in series and which is connected in parallel. This is to determine I, this is to determine V. Current. What current? Yes, it is voltmeter is equal to measuring electric potential difference between 2 points in the circuit. Yes. Money drones current. What current? Yeah, ammeter current you are telling. Fine with that. Now tell me which one is connected in series and which one? Yeah, ammeter in series. Money drones. Yes, ammeter in series. And what about voltmeter? Yes, Rashmi. Yes, Aditya. And yes, volt in parallel. So this is a parallel combination, right? So yeah, let's move forward. Done with this? Ammeter in series. Yes. I have another trick also. I'll be telling many tricks in this session. Okay, stay tuned. Just ammeter connected in series, voltmeter in parallel. Yes. Yes, Harish. Voltmeter. Yes, Vemu, Aditya. Everyone, right answer. Okay. Parallel. Voltmeter, parallel. Yes, Harish. Okay. Let's move. We have Ohm's law. How many guys know this? Ohm's law. Very famous, right? Very important and not that difficult also. Ohm's law. And you may get the question on this, okay? Ohm's law, you have to write the statement, you have to write the what formula. If they ask for derivation, just a 2 to 3 steps, you can derive the formula also. And you know why Ohm's law is very important? Why people say Ohm's law is important? Because Ohm's law has application in different numericals also. While solving about Joule's law, we will be using Ohm's law. Okay, and if we solve about resistance, we will be using Ohm's law. Everywhere it is used, so it is important. Yes. Okay, so it is important. And what is the statement of Ohm's law? Right? So, yeah, right, okay, I'll be asking it later. So, what is the statement of, hello, yes, Harish, hello, okay, so see, what's the statement? Voltage across the conductor is directly proportional to the current flowing through the conductor. It provided all the physical conditions and temperature remain constant, right? Most repeated topics, yeah. Okay, so how to remember this statement is only with this equation you can remember the statement. Okay, only with this. Okay, if I make notes, instead of writing this statement, I'll write this one line. Okay, you're in 11th, yes. Okay. Okay, see here. Potential difference across the conductor, potential difference applied across the conductor is directly proportional to the current flowing through the conductor, keeping the physical quantities constant and temperature constant. Easy statement, Krishu. Yes. Now tell me, why should I keep temperature constant? What happens if I differ temperature? Why temperature is constant? Tell me, do you guys know that? Why should I keep temperature constant? Yes, can you tell me? No worries, Anvesh. Fine, you can join now. Okay, tell me quickly, why should I keep temperature constant? Do you guys know or you don't know? If you know, tell me the answer. Yes, money drones, if you know, tell me the answer. Why? What happens if I vary temperature? Yes, Ohm's law works at constant temperature, but why? Shall I tell? Shall I tell the answer? It's hard to explain. Let me explain. Because what happens here, when in physics we'll be deriving the equations, right? When we remove this proportional, okay? When we remove the proportional, we will introduce a proportionality constant. Electrons will gain energy, travel faster. Just like market, there are many people, high temperature, okay? In the fluctuation of temperature, collision, yeah, that was, I was waiting for Aditya. Resistance will be changed, but we don't want resistance to be changed, okay? Here, okay? So, when we remove proportional symbol, okay, then fine. Resistance is directly proportional to temperature. Yes, Krishu. Yes. Yes. Okay. So, this voltage, when we remove proportional symbol, we introduce proportionality constant, that is resistance. We want this, what I called this? I called this as proportionality constant. You can see this, right? Yeah. Proportionality constant. When I say it as constant, it should not vary. Okay, you know it, Aditya. Fine, good for that. Yes, if we remove proportional, R will be introduced, which is constant. Yes, Adi, yes. Okay, with another device. Okay, you're the one. Okay. Explain it again, Anvesh. No worries, Vignesh, V is equal to IR, right? So see, Ohm's law states that potential across the conductor is directly proportional to the current at constant temperature. Why temperature should be constant? Because when we remove this proportional symbol, we introduce proportionality constant. Constant means it should be same, it should not vary. If I vary temperature, this resistance gets varied, okay. I don't want this resistance to change, so I will keep the temperature constant. Got the point now? Is it too much or okay? Tell me. Getting the point? I don't want my resistance to change, so I'll keep the temperature constant because both are directly proportional. Done? Yeah, Anvesh, you asked to explain it again. I hope you got it now. Right. Yes, fine. Okay, question. Let's solve again a question we have on our screen. EMF source of 88 volt. Okay, it's not 88, it's 8 volt. Yes, yes. Okay, fine. Ankush, yeah, fine. Okay, EMF, it's of 8 volt connected purely resistive electrical circuit. Okay, a current of 2 ampere is flows through the circuit. Consider conducting wires to be resistance free. Calculate. Okay, I hope this is also easy. Right? Why is resistance of conductor less than insulator? No, insulator has high resistance. Yes, yes. Resistance is less in conductors. Sorry. 4 ohm, 4 ohm. Yes, I'll see that. So you have asked the question, right, Krishu? Resistance, why it is less in conductors? You know, if you study it in more detail, there will be there will be different levels of bands. Simply, if I can explain, here there is conduction band. Okay, do you guys know about this? Tell me, conduction band and valence band. Do you guys have studied about this or not? I don't know when it comes in 11th or before only. So tell me. Yeah, 4 ohms. Yes, 4 ohms are appearing. Now tell me guys, do you know about conduction band and valence band? Tell me that answer in the chat. Do you guys know about that? 8 volt, I is equals to 2 ampere. We want R. We have V is equals to IR. R will be equal to V by I. 8 by 2, 4 ampere. Done. Yes, it's 4 ampere. No. Okay, fine. If you guys don't know that, then how can I say this? Okay, let it be. In conductors, no, the free electron, there will be more space for electrons to roam freely. Okay, you don't have that concept. No worries. In the 11th standard or 12th, you will be studying that. 12th physics, you'll get about that. Okay, no worries about that. Now just remember, why conductors has less resistance? Because electrons have free space to move, so they will move around easily. And in insulators, there are no that kind of space and energy, okay, so they will not move. Ma'am, it is ohm. Okay, I have written ampere. Sorry for that. Yeah. Done. Yes, in 11th class, you'll be having various conduction band, valence band and all. Okay, done Krishu? Fine. So this was also a easy question. Let's move forward. We are with the concept of resistance. Resistance is nothing but hump on the road which stops you to go forward. Yeah, I saw it, Adi, I saw it. Just sorry for that. Ma'am, is the energy level in solid medium conduction band? Yes, in conduction band, the energy levels will be very near. So electrons will move from here to here. But in insulators, distance will be far. So they cannot go from here to here. Okay, getting the point. In conduction band, the electrons will jump and they move. But in insulators, it is very far. They will not move. Done? Physical chemistry. Okay, in that you have. In physical chemistry, you have about the bands, energy. Resistance is property of resist. Yeah. Conductor T. Yeah. Okay. Good evening, Harshit. Good evening. Yeah. Just like copper wire we use because nucleus is big, so electrons are corner and it is easy to flow of electrons. Okay. My name is Adil. Okay. Okay. I missed the L. Right. Maybe. Okay. Come here. Come here to the resistance concept. This, yeah, resistance is nothing but some opposition when you'll feel while you're moving. Okay. Sorry for that, Adil. Okay. Right. Okay. So see here, resistance is nothing but opposition offered to the flow of current, flow of electrons, flow of charges, anything you can call. Okay, it's just the opposition that offers. Now we should study how it varies with length, area and temperature. Yeah, if you know the formula to calculate resistance, just write it down in the chat. Or tell me the relation between resistance, length of the conductor, area of the conductor, resistivity, temperature. So you can get a question on this, okay? This is also important concept. They'll be asking about, tell the properties or tell on which factors does the resistance depend. They'll be asking about this, okay? This is also important. From what metal nichrome is made up of and why it has high resistance? Okay, Krishu. So they'll be using alloys mixture, I hope. Okay, you should get the chemistry view of that. Nichrome, which metal and all. Okay, nichrome wires will be having high resistance. What metals nichrome is made up of? You should go and check out that. Fine. Alloy. So its resistance is high. Okay, it's the mixture. R is equals to rho L by A. Right Ankush. R is equals to rho L by A. How to remember this? Okay, how to remember this? Directly to I, inversely to A, proportional to R. T means temperature. Okay. Yes, Krishu. Okay, yeah, I have checked out that, but yeah, it's just alloy. It's not in detail that how nichrome is made, right? Okay, let me come to the resistance. So how do you remember about resistance? Okay, see here, resistance is directly proportional to length. If you want to travel a small distance, it is easy. If you want to travel a long distance, you will get more disturbance. Your vehicle will be slow. Okay. Yes, Muskan, absolutely. It depends upon the length, area of the section. Done. Okay. See here, when you have to travel a long distance, more length, more difficulty, more resistance. What can be the factor of resistant wires? Yeah, what are the factors on which resistance depend? Yes, Anvish. Okay, so remember, when you have to travel longer distance, you'll feel more difficulty. Similarly, when you have to travel in a narrow area, okay, there is some rigid narrow path, so it is not so convenient. When the area is very big, free, okay, this if you consider this to be a big area, if 5 people are standing here, one will be here, one will be here, it's not disturbance for you. You can aramse go on this road. But when area is less, the people will be crowded, so you cannot move fastly. Okay, so resistance is inversely proportional to area. If area is big, resistance is less. If area is small, you feel more resistance. Can you remember with these examples? Tell me now. And what happens when we increase temperature? The electrons will gain energy. Okay, electrons will gain energy and they'll rapidly move inside that and they collide with each other on the conductor also. So again, their speed reduces, they lose their energy, so there is no current. Yeah, you are writing about the SI unit? Yes, oh, yeah. Okay, got the point. When temperature increases, random motion of electron increases, okay. Electrons motion increases, that causes collision. When there is collision, it's directly proportional to resistance. Clear till here? Tell me in the chat, clear? Clear about these all things? Story of resistance. This is the story of resistance. Doubt? Yes, Dhyan, yeah, you can ask. Any doubt, you can ask that, no worries. Tell me quickly. Shall I move? If you have any question, you can ask. Till here? Yes, Dhyan, any doubt you can ask? Okay, so we shall move forward. And yes, if you have doubt, you can ask that. I'll be replying to that. Okay, no worries. So this is your formula. We are done with this. Moving forward. Yes, Rashmi. Okay, the concept of resistivity. Now here, okay, let me just write. Here we'll be writing like R is directly proportional to L, R is inversely proportional to A. Then when we combine this, okay, if you get the derivation, you must know to do this, okay. SI unit of resistivity, yeah, ohm meter. So this is directly proportional to L, A. When we remove proportional symbol, good afternoon, Archana, right? Yeah, good afternoon. It's evening, right? Now? Yeah. Okay, see here. When we remove this proportional symbol, we will introduce a proportionality constant. It is known as rho. Okay, now I am talking about this rho proportionality. Okay, you want some practice book? You're getting the answer in the chat. Verification of Ohm's law. Thank you. Okay, so yeah, first please do good with the NCERT, okay? Without missing NCERT, don't go to any other book. First deal with NCERT, clear it, then you can check out. If you want, I'll just go through the other things and I'll see you, okay? No worries. So Ohm's law, you want verification. What kind of verification? Here simply I have derived within a 2 steps, okay? Okay, Ohm's law. Yeah, V is directly proportional to I. You will remove proportional symbol, introduce proportionality constant. That's all. Yeah, let's move here. Now I am talking about this rho. That is nothing but resistivity. Yeah, sample papers, previous year question paper, you should not miss that. And we have that questions, okay? The students who don't know about that, last 5-year question paper, you can get it. Okay? Okay, about by graph. Okay. Oh, I missed that. I'll be telling about that. Don't worry. Okay? Yeah, let me first finish. I'm taking the row from here. You want a graph, right? Let me use that. See, from the graph, if you want to know Ohm's law, okay, in which axis should I take V and which axis should I take I to get R, the slope, okay? I want to get the slope to be resistance. Now tell me where I should use. So this is x-axis, what should I use here? Y-axis, what should I use here? So that I can get the resistance slope. Tell me quickly in the chat. Yes, students? Resistance is what it is made of which material, and every conductor has its own resistance. Yeah, of matter or not. Yeah, every different conductors has different its own resistivity it will be having. Tell me now quickly, in y-axis what should I use? In x-axis current. Yes, Diha. In y-axis I'll be using, x-axis I'll be using current, and y-axis I'll be using potential difference. You know how to remember this? If you get confused with should I use V here, I here, or like this, you can just remember in the y-axis, okay, in the y-axis you will be using voltage, that is V. Why only telling? I'll be using voltage, okay? Yes, Vaimu, it's right. So remember it like this. Yeah, Y for V, you can remember like that. Potential difference in the y-axis, fine. So this graph, this slope is nothing but, what is slope mathematically? You know it. Opposite by adjacent we'll be taking. So what is opposite? R is equals to V by I, right? So here R is equals to V by I. This is the slope and that we will get the R. Yes, it's not used here anywhere, right? Okay, it's like proven, I think. Okay, so let's move to the resistivity which came during resistance. Okay, yeah. Resistivity is defined as the, what is that? It's the resistance per unit length per unit cross section in area. So what is the formula? See here, resistance is equals to rho L by A. Resistivity is equals to R into A by L. So this is the formula to calculate resistivity. Is that clear? Is that clear? See here, resistivity depends upon nature of the material and temperatures, physical condition like temperature. Converging, yeah. What's that? I didn't got. Okay, shall we solve this question? Shall we solve this question now? What will be the resistivity of metal 2 meter length wire, 0.6 meter diameter and 5 ohm resistance? They have asked us to calculate resistivity. Calculate the answer and tell the answer in the chat. Right, calculate it. L is equals to 2 meter. D is equals to 0.6 millimeter. R is equals to D by 2. Yes, tell the answer in the chat. Okay. Tell the answer in the chat. Done, students? Done with the answer? Tell me. Now what should I use? 10 power plus 3 or minus 3? Yes, I have explained this, right? Can you tell the answer, students? Shall I proceed? Yeah. I'm not smart as you guys, right? Let it be. Okay, come here. Tell me, I'll be moving forward. If you will not tell answer, I'll be solving by myself. Okay. Okay. A is equals to pi r square 3.14 into, I'll convert this into 3 into 10 power minus 4 whole square. Tell me, do you guys want me to explain this? Want me to explain this? Yeah, quickly. Into 9 into 10 power minus 8. 9 4s are, it is 30. Right? Yeah, it's 36. Tell me the answer. Tell the answer. Is this, yeah, 9 on the 9, 10, 11, 12. 9, 10, 11, 12. Yes? Okay, I'll be waiting. Tell the answer. 9 3s are 27. Yeah, 28. Into 10 power minus 8. 2.826 into 10 power minus 8. Oh, here 9 it is. Yeah, explain. Yeah, I'll be explaining that, don't worry. What is this? Area. I have just found area. The rest calculation has to be done. So see, I'll be explaining now, okay? So they have given length. I don't want to change it. I'll keep it as it is. They have given diameter, but I want to calculate area. Resistance you have calculated, Aditya, 7.969 into 10 power. What's that? Okay, minus 8. It's not visible clearly. Fine. See here, R is equals to diameter by 2. This is the diameter. this is full is diameter, I want radius, so I have divided it with 2. So I got in millimeter, I don't want in millimeter, I want in meter. So I have introduced here 10 power minus 3 meters. Is that clear? Then we have to calculate area. Area formula is pi r square. Pi is 3.14, r we have calculated. I have just changed this to 3 into 10 power minus 4 meters. Okay. Done. So yeah, I am explaining here, right? So I have used this, square it, you will get 9 into 10 power minus 8, multiply 9 and 3.14, you will get this number 28.26 into 26 into 10 power minus 8. Just I have shifted this point from here to here, okay. I have reduced the number, right. So it's 10 power, yeah, just a second. I have reduced the number, so I have to increase here. Yes. Yes, see here. So it was 28.26. I made it 2.86. Okay. So I will add 1 power here. It will be minus 7. Done. Done with area. Shall I move? We have to calculate resistivity, right? We have to calculate resistivity. And it is R into L by A. R they have given 50 into L is 2 by A is 2.826. Okay. Is that clear? Right. Okay. If you cancel this, if you and power was 10 power minus 7. Okay. Tell me. Is this clear? Till here, is this clear? Tell me quickly. Yes, Aditya has given the answer. Whenever numericals comes, you'll feel. And when it's theory, it's good. But it should not be like that. You must understand the numericals also. If there is calculation and all, we can deal with that, okay? But you know concept, right? You know we have to use area, and you know in area we want radius. So you should go. If you can't go in this manner, trace the formula in backward direction. That is, use this formula first, then you will get to know I have to calculate area. Go to this formula, then you will get to know I have to calculate radius, and by this way you can reverse calculation you can do. If you feel confusion, okay? Done? Hi. Numerical? No, don't worry about, yeah, you have written the answer, right? Let me move to the answer. And yes, the answer is 7.06. No worries, a bit difference. But yeah, we have to go with the calculation, and it's 10 power 6. Okay. Tell me now. So we have did till here, right? Here we have to cancel. So 225 is the right 50. 25 into 2 point, if you do, see here. It was, we have calculated till here and we have did this step, right? 286 into 10 power minus 7. Yes, rest the things is multiplication. Yeah, screen background is okay. It should be light colors. Okay. So what you are telling, you want the light color screen background. If I will use some dark colors, I can use more colors, color pens here, right? So I was telling. Now tell this answer here. This is a fantastic question. Okay, here we have a nice question. Study the VI graph for 4 conductors ABCD having resistance RA, RB, RC, RD respectively. Which one of the following relation is true for the condition? Now, yeah, I'll just move this side. See this graph and tell the right relation between the resistance. Dark color demotivates. Okay. Yeah. But here if I use some other colors, you will not be able to see. Only if I use black you can see on the screen. Okay. Yeah, tell me the answer. Why do the dark color demotivates? Option A. Then, yes students. C, A. Yeah. Let the answers come. Okay, again. Yes. Who are the students watching? How many students you are watching? Tell the answer, right? So yeah, many students are watching. Tell the answer. Yes, Krishu, you are writing A. Let me check. Let others also answer. Let's wait for them. Yes, tell the answer. Only these many 3 students know the answer. Rest of the students, this moved. Okay. Rest of the students, what's the answer? Okay, let's check out. We have Aditya and Krishu A, and yeah, C, Rise Up has given the answer. C, let me deal with this. Okay, let's go to the Ohm's law. Okay, what happened to the screen? Just a second. Okay. Yes, just a second. Okay. B, you have given now B, you have written C. So what's the answer? Ohm's law, V is equals to IR. I want to know about R, which is equal to V by I. Which has highest voltage? It will have more resistance. Which one? Which one has? Yes, it is A. Only by one resistance I can tell, yes, first one is option A is the right answer. We don't need to see about other questions, right? Other options. Yes, it's not B or it's not C, it is option A, because from Ohm's law, if you rearrange the equation, you will get this equation. Where voltage is more, their resistance will be more. Okay, see here I found 1, 2, 3, 4 and 5. So this carries the higher, larger number. Okay, you must be know to how to analyze the graphs. Okay, graph analysis should be, you must know that. So whenever we go in this direction, it is increasing with the number, and similarly here 1, 2, 3, as we go upward, numbers increases. Right? I'm from Bangalore, right, in Karnataka. We are teaching from here. Okay. Yeah, let's move to the third question. Okay, question number 3. For a metallic conductor, current versus, that is nothing but IV. Yeah, voltage current graph is drawn at 2 different temperatures, T1 and T2 from the graph. Okay, what we should tell? Okay, relation between the temperature. Now tell which is the right option. 1, 2, 3, 4, A, B, C, D. Yes, students, what's the right answer? We have a graph that is voltage versus current graph. Now we have to tell the relation between temperature. Write down the option in the chat. Yes, what's the right option? Quickly in the chat. Can I know? Yes. In the chat. Yes, students. Option C. Option B. C, B. Okay. C, C, C. Okay. If I don't tell the answer, you will be just spamming the chat. So let me discuss. So what's the temperature? Okay. How to answer this? You think A, people think C, and etc. Okay. How to answer this? Again, I'll go to the Ohm's law. V is equals to IR. Right? So R is equals to, again, V by I. R is directly proportional to temperature. R is directly proportional to voltage. Okay, from these two statements, yes, C. Okay, Rashmi, I'll be checking that. So from this statement, I can write voltage is proportional to temperature, right? So which has highest voltage? T1. So the option C is right answer. Why? Okay, so option C is right answer. Okay, it's not A, it's not B, it's not D. It's option C. Fine. Tell me, is this clear? Did you use this method to answer the question? Yeah? Shall I move forward? Okay. I'm not that good in metals, alloys. Okay. I'm good with physics, right? Shall I move? Okay, done. Okay. So resistance, system of resistance. Till here we were just discussing about one resistance. But in real life, when you see the circuits in your home, school, all clear, done, thank you. Okay, in the practical real life, if we see, there will be not only one resistance, there will be combination of resistance, and we will be discussing about that. Before that, we have a question here. Why copper wires are used instead of silver? Okay, why copper? Silver, why ma'am we should use silver? Because its resistivity is low. Okay, resistivity of silver is less than all. Then why do we not use silver in these wires? Why? Tell the answer. It's on your screen also. Okay, why do we use coppers instead of silver? And the very basic general normal answer is silver is expensive. Yes, Krishu. General answer. You don't need physics to answer that question, right? But the second point is silver is malleable. Malleable means it can lose its shape, right? Copper is cheaper. Okay, you have written yes instead of C, I hope. Okay, so yeah, it's malleable. Malleable means, yes Rashmi, it's expensive. Malleable means it will lose its shape. What happens if it loses its shape? Wire, that closed path will get broken and current will not flow. Turns into sheets. Yeah. It will lose its shape. Yeah. Yes, malleable, which can be ductile and malleable. You have been studying about that properties, no? Ductile means it's a thin wire, and malleable. Yeah. Done. Okay. Series combination. Okay. Yeah? Okay. So what is series combination? If we are connecting something like this, okay, this is one particle, this is one particle, and we are connecting one after the other. So this is a series combination. And what is parallel? One upon the other. One after the other, series combination. One upon another, it's a parallel combination. You guys know this, right? Okay. So see here, one after the other, when we connect it, we call it as series combination. P is equals to Q by T. Yes. Current constant, voltage varies. About what? Current constant, voltage. Yeah. In series combination. Right. Do you know how I remember current is constant? I have again a trick here to remember current is constant. I'll just make this name. Anything. I Siri. Okay. It's our name. You can just remember the name. What I said? I Siri. I means current. Siri means series. Constant. Current is constant in series combination. This statement can be remembered with the name of I Siri. Done? Okay. Current is constant in series combination, but potential difference varies. But the potential difference will be equal to the sum of potential at different resistance. Shall we derive this now? Shall I derive? Tell me quickly. Yeah, I'll be creating my own tricks to remember the things. Okay. Yeah, I like to remember like that. So shall I start the derivation? Tell me quickly. Shall I start with the derivation? Tell me quickly. Yes. So let me start with the derivation now. Okay. So let me first draw 3 resistance. 1, 2 and 3. Let me apply a potential here. I'll call this as R1, R2 and R3. This is V. And yes, current is flowing thiswards. Yeah, just a second. Just a second. Yeah. Done. Let me not spend more time in drawing this. Let me start. Parallel resistance. Yes, that will be discussed, Vignesh. First, let's deal with series. Okay. Yeah. Okay. Resistance in series. Yeah. First, let us write that. Okay. First, let me write. We said that current is constant in series combination, right? So I'll write that. I is constant in series combination. Okay, I'll not be writing each and every word. The main concept is, oh, why have I written this is equal? The main concept is to remember to see the derivation. Okay. Okay. Now listen here. What's next? Potential difference is the sum of potential. Okay. This V will be equal to V1 plus V2 plus V3. That I'll be writing here. Voltage V is equals to V1 plus V2 plus V3. Is it clear? Do you know Hindi? Yeah. And Muskan, ma'am, positive, negative charge. Yeah, what you are asking about positive and negative charge? Yeah, Krishu, I know Hindi, but not that good. Okay. Being from South India, it's a bit difficult to speak Hindi, but I can understand and I can speak a bit. Okay. So yeah, positive, negative charge. What about that? See here. You guys know this derivation. Tell me the next step. What should I do? Tell me the next step. Tell me the next step. Quickly. Yes, students in the chat. Why it's so delay? Okay, tell me in the chat. What's the next step I should use here? Yes, can I know? Yes, can I know? What's the next step? Okay. Ma'am, positive, negative charge. Okay, tell me the next step. Shall I move? Okay. So, from Ohm's law. So, why Ohm's law is important? Here we are using. So, it is important. From Ohm's law, we know that V is equals to IR, right? In the place of V, I'll be substituting IR. Okay, here you're telling about this. Fine. Yes, V1 is equals to, V is equal to IR, V1 is equals to I1. I can write I1 plus R1 and all, but here I is same. So, I will not write again I1. I will just write it I plus R2, I plus R3. Now, next step is taking out I common. So remaining will be R1 plus R2 plus R3. I will get cancelled, right? Yes, and many more. Yeah. So R will be equal to, in series combination, the effective resistance is R1 plus R2 plus R3. If there are n number of resistance, yeah, my name is Neha. Okay, it will be on thumbnail and the title also, you can know it. Yes, AI motivation, right? So this is the formula to calculate in series resistance. If there are n number of resistance, you will be continuing R3, R4, R4, R5 and so on. So if there is similar kind of, get my point. Okay, instead of R1, R2, yeah, if you have any doubt, you can ask. Yes, Shahid Khan. Okay, if this is instead of R1, if there is R, okay, n number of resistance. Okay, remember this also. Remember this formula also. Instead of R1, R2, R3, if there is R n times, then the equivalent resistance will be equal to NR. This formula will also be helpful. Yeah, if you have doubt, you can ask, I said, right? Is this clear, students? Is the both formulas clear? This is for different resistance. This is for same resistance. Tell me quickly in the chat. Shall I proceed? Done with this resistance in series. Yes, tell me quickly. Shall I move? Shall I proceed? Yes. Did you guys understood? Yes. Okay. Then let's move. Till here you can see, I hope. You are able to see these things. That's enough. That's enough, right? You can see this formula, that's enough. Okay. Let's move forward. Going towards the, okay, question. Easy question again. Quickly tell me the answer. Yeah, tell me the answer. Good evening, Saksham. Tell me the answer. Do you want me to solve this? Yeah, done. It will be still some more time, okay? We are at, we should discuss about parallel combination, then about Joule's law. There are some concepts still left, okay? Yeah, resistivity is done. Okay? Thank you. Tell me the answer in the chat. If you make delay, the session will go delay. If you tell the answer quickly, we can just jump on to next. Okay? If you tell the answer quickly, we can move. Tell the answer. See here, series combination, 3 resistance are given, voltage is given. They are asking us to find the equivalent resistance and current. This is R1 plus R2 plus R3, as I said. Tell the answer. So it is 10 plus 20 plus 30. Right? 4 ohm, 4 ampere. What is the equivalent resistance? 30, 50, 60. No answers about this. Why? Is this so difficult one? 60 ohm. Okay. Now current. What's the formula to calculate current? I is equals to V by R, right? V is 240. R is 60. Yes. 6 4s are. Yes. 6 4s are. It's 24. So it is 4 ampere. Done with this. Done with this. Tell me quickly. Yeah, I hope this is clear. Concentrate, students. I'm asking for your answer. Okay. I would like if you replay the answers, right, in the chat. Right? Yeah. Shall I proceed? I hope it's clear. 24. What? Nothing is 24 here. Okay. It's 60 and 4. Done. Done, 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 done. Okay, let's move. Let's move to the parallel combination. So as I said before, what is parallel combination? One upon the other. So you can see here where ends are connected together is called as parallel combination. And voltage, this is not series, in parallel combination. Voltage is same in parallel combination. Okay. Yeah. So yeah, next what we have? Here the total current will be equal to sum of each current. Shall I derive this one? Shall we derive? Yes, quickly, let's derive. Let's not take more time. I'll be deriving quickly. Yeah, social will also be started. Okay, Navya ma'am has already started with today, right? So I'll be dealing with the history concepts. Once let me finish all your physics that is chapters, then I'll enter to history. Okay. Okay. So resistance in parallel combination. Okay. No, it is divided by, right? 240 by 6. Okay. Yeah. Let me start with this parallel combination. Let me call this R1, R2 and R3. This is RV and our current is flowing in this direction. Done. Okay. Let me solve. Yeah, let me derive. Okay. Yeah, done. So let me derive. So what I said here, the voltage is same. Voltage is same is nothing but V is equals to V1. Why this is plus? V2 is equals to V3. Just a second. Here voltage is same but current is changed. Okay. Let's concentrate on the topic, students. Your exams are arising, right? So I'm teaching for your exams, right? So here the current is sum of the current at different resistance. Again with the Ohm's law, right? That is V is equal to IR. In the place of I'll be substituting V by R. Fine? Fine? 10 days are left for both, so please. Yeah, these are one shot videos. Don't worry about that, okay? Yes, one shot videos, but little it's detailed, so you will not waste more time, okay? Done? Right. So here it is V by R. So I'm solving here quickly for you guys, right? This is again I'll not write V1 because it is same. Quickly, let me solve this. I'll take out V common and remaining is 1 by R1 plus 1 by R2 plus 1 by R3. V gets cancelled. Okay. So what's the final answer? Equivalent resistance in parallel 1 by Rp is equals to 1 by R1 plus 1 by R2 plus 1 by R3. This is your formula to calculate parallel resistance. Is this clear? Tell me quickly in the chat. Again, if the resistance is R, N times, then the total parallel resistance will be equal to N by R. Okay. Done. Shall I move then? Yes, shall I move? Okay. Okay. Yes. Done with this. Right? I hope there is no question here. Yes? Yes. Then we will move to the next question. Yeah, answer to this question quickly. It's also direct question. Two resistance are given which are in parallel combination. Voltage is given. We have to calculate total resistance and current. Yeah, and current. Yeah, calculate it quickly. Calculate the answer. Yes, 1 by Rp is equals to 1 by 20 plus 1 by 30 LCM is 60. Here it is 3 plus 2. So it is 560, right? Yeah. What's the answer? Yes, answer. Students, what's the answer? Then we have to calculate I. V by R. What is V? Find the through the circuit, okay? Okay. What is V? 5. What is RP? 12. Yes, 0.25 ampere, 12 ohm, 12 ohm. Yes, absolutely right. It's 12 ohm. 0.25. Yeah. Is it 0. Yeah, let's check. 2. 0.25. You guys said, right? 24. Forza. Just a second. It's not 0.25. Why you guys wrote that? It's not 0.25. It's 4 point. See here. 12 ones are, 12 fours are, we'll calculate. 12 fours are 48. So again 2 remaining. There's a point, 0. Then 12 2s are 24. Again 12 ones are here. Can you guys see here what I'm writing? Is it visible? Yeah, it's not 0.25. Okay, okay Krishu. So it's 0.41. So here again, if I remove 12, 8 will be remaining. So 7, 0.417, 7 or 6, anything. The last digit may vary, but it is 0.4 ampere. Fine? Okay, shall I move? Tell me. I hope this is done. Yeah? Now we are entering to the Joule's law. Joule's law that is deals with the heating effect of current, okay? Here we are dealing with the heating effect of current. Joule's law of heating states that, what it states? Yeah, okay. What it states, heat generated by the electrical conductor is proportional to the, simply don't mug up the statements. Heat generated in the conductor is directly proportional to the square of current flowing through the conductor. It's directly proportional to the resistance of the conductor and time of flow of current. This is the statement and this is the formula 2. Okay, this is the formula to calculate heat generated in the conductor. Is this clear? Yes, yes Krishu, H is equal to I square RT. Done? Done with this? Tell me. Shall I proceed? Okay. Yeah. The next one is about cost calculation, which you will be getting in your examination. So how to calculate the cost? Okay, cost of anything. So first you have to calculate the energy used in kilowatt hour. So whatever second they have given or in the watts they have given, you have to convert it into kilowatt hour. Okay. Done. Then you have to multiply it with number of days. How to do that? I'll be showing you. Don't worry about that. Right? So they will be given about the cost of 1 unit. They'll be given the cost of 1 unit is 3 rupees, 5 rupees, something like that. We have to multiply that. Multiply the energy into given cost. You'll get the answer. Right? So yeah, we will be discussing that here. Okay? How to solve that? I'll be showing you here. If the unit of cost of electricity is 3 per commercial unit, okay, they have given the cost. As I said, they'll be giving cost per unit for 1 kilowatt. For 1 kilowatt hour, the cost is 3 rupees. Okay, they have used 1000 watt for 2 hours, 28 days. Okay, yeah, calculate the answer. Calculate the answer. So we have to calculate first the total energy used. It is 1000 watt into for 2 hours into 28 days. So what is the total energy used? Yes, it is 56 into 1, 2, 3 zeros. if I convert, this is watt. If I convert to kilowatt, what happens? These 3 zeros will go. So it is 56 kilowatt hours. Yeah, it is directly, they have given hours. Okay, this is watt hour. Done? Tell me in the chat, is this done? Did you guys got this point? Tell me. Tell me quickly in the chat. Yes? Shall I proceed? Tell me quickly in the chat. Yeah? Did you guys got this point? Yes, I hope it's done. Moving forward to the cost. The cost will be total energy used in kilowatt hour into the price of 1. So it is 56. Yeah. So I'm waiting for your answer. Ma'am, there are 28 days, not hours. But this is 2 hours. Right. Okay, so there is hour again. So yes, multiply this. 18, 1, 15 plus 1, 16. Yeah, it is 168. Done. Days are not needed to convert into, the answer is not given here, or else we could check that. Right? Days need not to be converted in hours. They have given here 2 hours. It is for 28 days. Right? Okay, let me read out this quickly. Okay, again you have the sessions, right? So yeah, electric bulb. In the electric bulb we will be having tungsten metal. So what's the function of tungsten metal? It will not melt easily. It will be having high melting point. Why it should not melt easily? Okay. You guys are watching me and you don't know my name. Neha, N-E-H-A. Okay, my name is. You don't know my name. You'll be watching my sessions. Okay, no, fine, fine. No worries, Rizal. Okay. So yeah, tungsten metal will be used in the bulb so that its melting point is high. It will not melt inside the bulb, or else bulb will not work. Okay, so it's like that. We'll be using some natural gases also, which you'll get. Yeah, Neha ma'am. Yes, yes, Rashmi. Okay, we'll be using natural gases and we'll be using some aids so that it will not melt. It should be hard enough and it should eject the light. It's about your electric bulb. Coming to the fuse, fuse is used. We'll be using the metals alloys, okay? Metals and alloys to make the inner wiring of the fuse if we heat much, okay? Why fuse is used? Fuse is used to save our electrical appliances, right? Whenever there is more flow of electric current, what happens? This has low melting point and wires will melt. They will break the circuit. Current will not flow. Okay, so it happens like that. Fine. Okay, it is about fuse. Now what we have, the process in which, yeah, this is process is earthing. Okay, just a second. Earthing is nothing but the process where we use to the metallic, what we can say, metallic objects, okay, like refrigerators and all. Why do we use tungsten? Because it has high melting point, one reason, and another reason is it will convert heat energy into light energy, right? We want the light from the bulb, okay? Let's be quick. Earthing process is done where the earthing wire will be having low resistance. If the current is excess, if it is leaked, what happens? The current will flow through the earthing wire, it goes to the earth. Our appliances, our home will be safe. Okay? Yes, coming towards the electric power. So, power is equals to voltage into current. Okay, so I'm doing this quick, okay? So, but these formulas are important. So I'm telling that, I'm not leaving anything here. Okay, I don't want to skip the points. So power is equals to voltage into current. By using Ohm's law, you can substitute and find other formulas. You can see this in your textbook. The thing which I have converted is given here. Okay, so tungsten metal, we have to store that bulb with argon gases and all, right? So I hope it's not so reactive as other metals. So it's good to use there. Okay? Yeah. This is your homework question. Okay? I want the answer in the description. This is the last question we have. Okay? Answer in the comment section. Okay? Beginning of this session also I have displayed the names of the students who have answered to the last video which I was taking. Okay? Done? Write the answer in the comment. I'll be displaying your name tomorrow. Okay, tomorrow we'll be doing magnetic effects of current. Done, students. So let's not waste much time. So yeah, this was about today's video. I hope you liked today's video, right? If you have liked the video, just hit the like button and share the video with your friends. And yeah, thank you so much for watching this video. Let's meet again tomorrow in the next session. Bye bye. Thank you.